Alright, this video is on simplifying and working out some basic factorial expressions. I did one before, but the comments essentially were, can you narrate it and discuss it versus just putting on some classical music. So that's what this one's for. So before we get started into some of the nuances, if you're here, you probably know at least the basics. For example, 5 factorial means 5 times 4 times 3 times 2 times 1, and that's 120. Okay. So you probably know how to work out the basic expressions. You might have some trouble with arrangements of letters and stuff, which we'll get to in just a moment. First of all, when it comes to what this is telling you, or at least one of the things that it's telling you, is that a factorial. Okay, I got Amadeus on in the background. Factorial expression tells you how many arrangements there are for n distinct items. Okay, so what does that mean? So for example, if you have ABC, you have 3 different letters here, and if you were to rearrange these, you would get ACB, you would get CAB, you would get CBA, you would get BCA, and you would get BAC. So in other words, this is your sample space. So if you're taking a statistics class, this would be your sample space, this picture right there. And since there are 3 distinct, or 3 different letters, there are 3 factorial ways to arrange these letters, or 3 times 2 times 1, which is 6. Okay. Now as a side note, really quick, 5 factorial times 3 factorial does not equal, don't do this please, does not equal 15 factorial. That is not how you evaluate the product of 2 factorials. You have to evaluate them individually. So 5 factorial, which you already know, we just did over here, is 120. Well, that's, I mean, my penmanship is bad, but that too is really bad. 120, and 3 factorial is 6, which we just did right there. So 5 factorial times 3 factorial is 120 times 6, or 720. Now you go ahead and work out 15 factorial. That is way larger than 720, okay? Because 15 factorial would be 15 times 14 times 13 times 12, etc. So if we were to work out, so let's go back to the arrangements of things. So if, for example, we had the word, let's start with one you probably already did in your class. If you wanted to figure out how many arrangements of letters there were, or there are, in the word mouse, well, because there are 5 distinct letters, 1, 2, 3, 4, 5, there are 5 factorial ways of rearranging those letters, which is, as you know, is 120, which is what we did right back up here. Okay, 5 factorial is 120. Now, if you don't believe me, go ahead and rearrange all those letters, and then come back, and then all you're going to do is you're going to get 120. So, of course, the question is, if there, for n items, there's n factorial ways to arrangement, what happens if you have repeated items? So, for example, if you change the U to an O, you get a moose. So how many ways are there to rearrange the letters in the word moose? Well, for starters, you still need the total count. 1, 2, 3, 4, 5. There are still 5 letters in the word moose. But you have these 2 repeated O's. And since changing these 2 O's doesn't change anything, you're going to have less arrangements of things. So if they were all different, you would have 120, but because you have the 2 repeated O's, 2 factorial, of course, is 2 times 1, which is 2. That gives you 60. So there are 60 different ways to rearrange the letters in the word, moose. So now let's take a look at, let's just make something up here. Suppose we have like A, B, B, B. That's a terrible looking B. Once again, it's not going to get much better. C, C, and D. Whatever. So, and you wanted to figure out how many different ways there were to rearrange these A's, B's, C's, and D's. Well, first, once again, the numerator is always the total. So we need to know how many letters there are. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 total letters in this string. But we've got some repeats. We've got 2 A's. Switching those A's doesn't matter. We've got 3 B's. And we've got 2 C's. Now we have 1 D, so if you want to write times 1 factorial, you can. But of course 1 factorial is just 1. So if we go ahead and work this out, what we're going to get is the denominator here. Well, 2 factorial is 2. 3 factorial is 6, which we already know from above. And 2 factorial is 2 again. Once again, do not multiply 2 times 3 times 2 and call that, what is that, 6, 12 factorial. 8 factorial is 40,320. So 8 factorial is 40,320. And if we go ahead and divide this by 2, then by 6, then by 2 again, we get 1680. So this is 1,000. Oh God! Once again, penmanship is terrible. I've learned to live with it, and I already forgot what that was. 1,680. So there are 1,680 ways of rearranging the letters in AA, BBB, CC, and D. So just for some practice, really quick, let's just make some stuff up here. How about calculus, Mississippi? Let's go ahead and MISSISSIPPI. And how about A, B, B, A, C, 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 D, and another A. Okay, so let's go ahead and, well, let's just set these up. I'll leave you to do the work with the calculator, but if you get the setup correct, then you know you're probably going to get the calculator part correct. So and if you want to, just pause it here and see if you can set these up correctly, and then come on back. Alright, so if you did work these out, let's see what you have here. Oops, we don't want that. We want this. So once again, the numerator is always the total, so 1, 2, 3, 4, 5, 6, 7, 8. So calculus has 8 letters, so there's 8 factorial. And there's 2 C's that are repeating, 2 U's that are repeating, so 2 factorial for the U's. It doesn't matter which order they're in, and it looks like 2 L's that are repeating, so 2 factorial there. Okay, now once again, you could do the arithmetic. In fact, we already have 8 factorial. It's 40,320. And we know 2 factorial is 2 times 2, so we got 8, so we can go ahead and give that a go. Alright, so for Mississippi, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 11 letters, which means 11 factorials in the numerator. And for our denominator, we've got 1, 2, 3, 4 S's. So 4 factorial for the S's. We've got the 2 P's, so 2 factorial for the P's. And once again, these don't have to be in any specific order. You're multiplying anyway. And it looks the 4 S's, the 2 P's, and the 4 I's. Okay, so that's the setup. Once again, just grab a calculator and go ahead and work that out. Now for this string of things, let's hope that I don't get this one messed up. First of all, once again, the numerator is just the total number, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like we have 12 letters. So there's 12 factorial ways in the numerator. Let's double check that one part. 3, 5, 6, 10, 12. And we have 1, 2, 3, 4, 5 repeated A's. Oh, God. Terrible. So 5 repeated A's. It looks like just 2 repeated B's. And so 5 repeated A's, 2 repeated B's, and 4 repeated C's. Okay, and once again, you could go ahead and put the D right here, 1 factorial, but that's not going to change anything. Okay, so go ahead and grab a calculator, and let's just work out this last one really quick. So we've got 12 factorial. It's a very big number. Oops, clear that. 12 factorial, and let's move this over. 12 factorial divided by 5 factorial is 120, divided by 2 for the 2 factorial, and divided by, well, what is that equal to? Phooey. 12 factorial divided by 120, okay, divided by 2, and divided by 4 factorial, which is 12. 4 times 3 times 2, and we get 166,320. 66,320. Okay. And that's how many. Now, if you don't believe me, go ahead and start rearranging those letters and then do the calculation, and you'll see that you get 166,320 if you have that kind of time on your hand. Hope this helps. Thanks for watching.